So for problems 6, 7, and 8, I'm going to do A of each, and then you need to do B on your own. Convert the following equation to factored form. So look, I'm starting out with standard. I want to move to factored. So that requires, for my students, we did the area model, right? We did the box. So this was a week and a half ago. You put the 6x squared here, right? You put the negative 5 here. And you remember that that negative 13x, whatever lands in here, you have to add to negative 13x, right? So the sum has to be negative 13x. And the product has to be this times this, negative 30x squared, right? So to figure out what goes in these two boxes, I need to figure out what adds to negative 13x, but what multiplies to negative 30x squared. So I just start by listing the factors. I start by saying, okay, well, 1 times negative 30 multiplies to this, but it doesn't add to negative 13. So 2 times negative 15, that multiplies to this, and it adds to that. So it looks like I just found 2 and negative 15. But don't forget you need the x, right? Because these add to negative 13x, they multiply to negative 30x squared. So don't forget the x's. So I'm going to put a 2x here, a negative 15x there. I'm not done, right? The whole goal is to use this to factor it. Remember, factored form is going to have things in parentheses, right? So I need to figure out what's on the outside of the box. So I start by pulling up my greatest common factor. So that's a 2 and then an x. And then I just ask myself, what do I need to multiply by here so that these two multiply to the inside of the box? Well, I need to multiply 2x times 3x to get 6x squared. Here, I need to multiply 2x times a 1 to get a 2x. Here, I need to multiply by a negative 5. Negative 5 times 3x will give me negative 15x. And then just double checking, does negative 5 times positive 1 equal negative 5? Yes. So at this point, then I can just read my factors. 2x minus 5 and 3x plus 1. So this is the factored form. And that's helpful because this shows you y-intercept, but this is going to show you x-intercept. So that gives you more information about the graph. Now you do B. So here, for 7a, now we're going to convert this to vertex form. So we have something in standard form, and we want to convert to vertex form. Now, you can watch the homework video from last week if you want to see how to use the algebra tiles to do that. So the vertex form problem from the homework videos last week, but I'm going to use the short version for how to do it with algebra, right? So remember, vertex form is where you have something in parentheses squared plus, so we've got x and then something here and then something here, right? So this is the general vertex form, and we need to figure out what this number is and what this number is. Well, remember, we learned that this number is just always going to be half of this. So taking half of this number, negative 18 is negative 9. Okay, so that's the easy one. So you should definitely be able to fill in this part. Half of that number, remember, because it's what made the sides of the algebra tiles. Now this one's a little more complicated, but we worked out last Friday that to figure out this number, you square this. You take negative 9 times negative 9, that's 81. And then that's how many, remember, little squares it would take to fill out. But you have negative 13 right here. You don't even have positives to fill it out. So you would need to subtract. You take this number, negative 13, minus this number squared, right? So that's going to be negative 94. And that's going to be your number right there, negative 94. So one more time. To get the number in here, it's just half of that. To get the number out here, we take this number minus this number squared, okay? And you do B, right? And number 8a, convert this to standard. So this is a vertex, and we need to go back to standard. So this right here is really just a multiplication problem, right? So this is something that you just need to be able to write this out. So we've got negative 2 times x plus 3 times x plus 3 plus 7. And now we can just use the distributive property. I personally prefer to organize my work this way, where I have the box, x plus 3 and x plus 3. So that's x squared, that's 3x, that's 9. So to figure out how to multiply those two together, I use the box. So now I can rewrite it. I still got the negative 2, but now I've got x squared plus 6x plus 9. And I'm still adding on that 7. So do you see I used the box to multiply these two. And you could have, if you had wanted, used the distributive property instead. Or that's what I used over here. I just organized it differently. But you would have gotten this. And now we still need to use the distributive property, right? I still need to multiply the negative 2 to everything. So negative 2x squared plus negative 12x plus negative 18 plus 7. And now I just need to combine like terms. These are the only like terms, so negative 2x squared plus negative 12x plus negative 11. And now is it in standard form? Absolutely. You've got your a value, your b value, your c value. So y equals this. So I was able to convert to from vertex to standard by just using basic multiplying polynomials and adding like terms. So you do B.